Hi folks, it's Dr. P. This video is all about how to use the function generator as a clock signal in digital systems. So if you are a circuit analysis student, you are going to want to watch my circuit analysis specific video about this function generator because you are going to be using it in very different ways. So the function generator is capable of creating a square wave signal for us that we can use as an on-off clock signal with voltages of 0 and 5 volts, generally when we are using sequential circuits. So when we're using flip-flops and we're designing finite state machines, we need to be able to create a clock signal. So you're going to create a clock signal using a 555 timer, but as you will see, using this function generator is much simpler. So the function generator is thankfully a relatively straightforward piece of equipment to use. There's not a whole lot of stuff that we're really going to be doing with it. So firstly is the power button. And when you hit the power button, you should notice that the indicators light up. If they do not, then it means that this is not plugged in. There are knobs, these dials, and then there are buttons on the top, buttons on the bottom, buttons in the upper right, and then more dials. So the good thing about digital is we don't have to use a lot of these buttons and dials because we're just using this for specifically square waves. So if you notice, these three upper right hand corner buttons have different shapes above them. This is for a sine wave, this is for a square wave, and this is for a triangle wave. We want to have the square wave pressed, but honestly it doesn't really matter which one we press because we're going to be using a specific output cable that will turn anything into a square wave. So if we look at the bottom, there are three different BNC connectors: VCG, which we will not use, output, which we will not use, and the one in the middle is called TTL CMOS. So this is what we want because we are using TTL devices and we want 0 to 5 volts square wave. This output forces anything that we press over here to be a square wave between 0 to 5. So even if I accidentally have this in sinusoid mode, or I have some type of offset or a duty cycle set, basically it's always going to force this to be 0 to 5 volts. So what I'm going to do is I'm going to plug the BNC cable into that TTL CMOS spot. And then the leads that we have are just regular old alligator clips. Red is high potential and black is low potential. So because you're going to be using the clock signal in addition to your power and ground connections from the DC source, it is imperative to make sure that you connect the ground low potential cable from this function generator into the same power rail as your ground signal from your DC power supply. So we call that a common ground, and you need to have a common ground in order for anything to work. Okay. This, however, is not connected to your VCC rail. That would be a very bad thing. So this is just going to be connected to whichever pin on your flip-flop or flip-flops need to go to the clock signal. So what I'm going to do is I'm just going to connect this to an LED so you can just kind of see what's going on as I change the functioning of this function generator. So right now, it doesn't really look like the LED is doing a heck of a lot, and that's because the frequency is just so fast that it's blinking faster than our eyes can see. So if we want to change the frequency, these are the buttons that enable us to do so. So the range is between 5 volts and 5 hertz and 5 megahertz. So we can start slow. And when we do that, we can see that this LED is blinking on and off now, slow enough that we can see it. For getting finer control rather than just these decade buttons, we can dial the coarse and the fine knobs. So you'll notice that it kind of took a little bit for this to update. So what happens in order for this indicator to update its value is it actually needs to kind of sample for a little while. And this is pretty slow. This is 1 hertz, which means this blinks on and off 1 time per second. So it can sometimes take a little while for it to update. So what I can do if I want to coarsely change the frequency is I can dial this knob, and we can see it's getting faster. And again, it's going to be a little bit before the indicator catches up and tells me what the new frequency is. So we just have to be patient. Okay, so 3.7 hertz. And then if I want fine-tune control, I can dial the fine knob And again, it might take a little bit for it to update. But what we're getting is a value from 0 to 5 volts, 0 to 5 volts, that's causing this LED to basically blink on and off, on and off. All of these buttons that are on the middle row are things that we do not need to press. So they should always be in the off position, which means sticking all the way out. And if you're not sure which one is off and on, there's that nice little handy guide that's printed on the front of the function generator. So we're not going to use any of them. The duty cycle changes how much this is on versus it's off. Okay, we don't want that. We just want a nice 50-50 on-off square wave. CMOS level, we're not using CMOS devices. That'll change the voltage to CMOS compatible. DC offset's not going to do anything because we're using this TTL CMOS connection. So there's really not a heck of a lot to this as far as digital systems goes. So again, if you're noticing that your signal is not working, common mistakes that I see are that students are using this output rather than using this TTL CMOS. So always use this TTL CMOS, the middle connection in digital systems, and then also make sure you have a common ground between the black alligator clip and your ground rail on your breadboard. All right, folks, that's all there is to the function generator. Until next time, stay well.